Okay, in these notes we're going to talk about volume and surface area, specifically of prisms. Those are the shapes we're going to start with here. So let's get right to it. So first of all, volume can be thought of the amount of stuff that a thing takes up, right? It's the amount of space that a figure takes up. You can also think of it as the amount of space or the amount of stuff you can fit into a figure, a 3D shape. Now, surface area is exactly what it sounds like. It's the area of all the outside surfaces of a figure. Okay, so volume is going to be given in a cubed unit, like inches cubed. Surface area is area, and so we're looking at inches squared, or whatever the unit is, squared. So now let's talk about prisms. A prism is a type of 3D shape that has congruent bases. So these two opposite sides are congruent. For example, a rectangular prism, and of course these are all rectangles, so you can think of them in multiple ways, but a rectangular prism has these two congruent opposite rectangles between four other sides. And because these are rectangles, any two pairs of opposite sides are going to be congruent here, but it is often helpful to think of just choose one of them to be kind of the bases. For a triangular prism, that's a little more obvious. The opposite congruent triangles are the bases here. Those are the congruent sides, and then you have the other three connectors. Now, depending on what the shape is of the base, that is the type of prism that you have. We're going to mainly focus on rectangular and triangular prisms in these notes, but you've got any shape you can have that prism. So like a hexagonal prism, septagonal prism, nonagonal prism, just any shape with any number of sides can be the base of a prism. So to find the volume of a prism, we just multiply the base area by the height of the prism. And you can think of that as a really basic formula, capital B, which is the area of the base times height. And the height of a prism is the distance between the bases. In those two examples, that would be the height. This length between the bases here. Now, for specific formulas, I like that general formula because as long as you understand that you're finding the area of the base times the height of the prism, you can apply that to any type of prism. But for a specific formula, a rectangular prism, we usually use length times width times height. So length and width is how you find the area of a rectangle, and then you multiply that by the height. For a triangular prism, you would have to find the area of the triangular base, which is 1/2 base times height, and then you have the height of the prism. And so this is confusing because we have two heights to worry about, right? So this is why I like to just use the general formula, height of the prism there, I guess. The general formula, capital B, which is the area of the base, times the height. And remember, for a triangle, the height is the perpendicular distance between the base of the triangle and the opposing corner. Okay, so that's a little more involved as far as a specific formula goes, and you can use capital H for the height of the prism, or some way to distinguish it between the height of the triangle. But that's why I like to talk about volume in terms of this formula, area of the base times the height. Now, to find the surface area of a prism, it's real simple. Just find the areas of all the sides and add those up together. So whatever shape the individual sides are, most of them will be rectangles. Just find them and add them up. So we're going to do a few examples here, a few different types. We'll see how this goes. So what we can do is use what's called a net to help us kind of visualize what's happening, because when you look at a rectangular prism like this, you actually do have 6 sides, 6 rectangles that make it up. And this is especially helpful when finding surface area. So for volume, again, we're just going to multiply the area of the base times the height. And so you can think of this bottom one here as the base, and then 4 is the height. All right, so it's kind of like taking 4 meters worth of this area of the base, which is 6, 3 times 2. So the volume here would be 3 times 2 times 4, which is 24 meters cubed. Right? But for the surface area, it can be easy to lose track and not count all 6 sides. So what you can do is kind of unfold the shape into what's called a net. It's kind of like taking apart a box. So you have to make sure you get the correct measurements on here. So we have these small ones that are 3 by 2. That would be these two here. We have these slightly longer ones that are 4 by 2. That would be these here. Maybe marking every side isn't necessary, it gets a little busy. Okay, and then we have the 2 sides here that are 4 by 3, and those are these here. Okay, so the 4 by 3 sides, those have an area of 12. 4 times 3 is 12. The 2 by 3 have an area of 6, and the 2 by 4 have an area of 8. So we have these 6 areas that we want to add together to find the total surface area. Right, 12 plus 12 plus 8 plus 8 plus 6 plus 6. And the surface area here would be 52 meters squared. Okay, now do you have to use a net every time? No, but it is helpful to kind of visualize what the shape looks like. So if you're having trouble getting all the sides and adding them up, often it is helpful to draw a net. And we'll draw a net for every example in the notes, but it's not 100% necessary for you to do every time. Just make sure you know what it means and you can visualize what it would fold back up into. Now let's look at a triangular prism here. So we have 2 triangles. And we have the height between them. So first of all, for the volume, we have to find the area of the triangular base. Right, so that would be 1/2 times 9 times 6. That is the area of this triangle here. It's 1/2 times 9 times 6. So 9 times 6 is 54. Half of that is 27 square kilometers. But we're going to have to multiply that by the height of the prism, which is 10. I shouldn't write that yet. So 1/2 times 9 times 6 times the height of the prism, which is 10. So 27 times 10 gives us 270 kilometers cubed. Quite a big prism. All right, but again, to find the surface area, you can just kind of mentally keep track of what sides, but it can also be helpful to draw a net. It's also important to know kind of what the net would look like for any given prism. So this is a triangular prism. So we have the 2 triangular bases, and they're connected by this rectangle here. So we can draw that. And then we have the 2 sides that kind of go between the other 2 points, the sides of the triangle. So, and you can draw them wherever. I like to just put them here because that just makes sense to me. But you can also draw them anywhere. You can put them here and here, but I like to just put them all the rectangles together and then put the bases at the bottom and top. So this is what that net would generally look like, and we can try to fill in these side lengths. So we know the triangles are 7 by 8 by 9. 9 being that bottom base that's against that middle rectangle. So we know 9 is here and here. And then 7 and 8 would be here, 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 and here. Okay, now the height between the two triangular bases is 10, so 10 would go here. And if this side of the triangle is 8, the side of that rectangle against it has to also be 8. So this rectangle is 8 by 10, and this rectangle is 7 by 10. Because these sides have to line up and be the same, and these sides have to be the same. So there we have our net. A little complicated, but it's really just a matter of unfolding this shape and seeing which sides are which. So now we just find the areas of each side here. We know the triangle has an area of 27, so both the triangles have the same area. And the three rectangles are 70, 90, and 80. So those are our 5 sides to add up. 70 plus 90 plus 80 plus 27 plus 27 gives us 294 kilometers squared. Now we have a description of a rectangular prism with dimensions of 10, 9, and 8. So you can try to draw a really quick one. Or you just know that it's, the volume is length times width times height. So we can just do that really quick with the volume. 10 times 9 times 8 is 720 inches cubed. Now to draw the net, any rectangular prism is going to use this kind of same shape right here, these 6 sides. So we can try to draw that really simply. Kind of like this. Now we just have to make sure we get the measurements put on there correctly. So we have one, you can think of this as the bottom, this 10 by 9 here, and then we have some 10 by 8s. This one also has to be 8 here. This is 9. This would also be 8. These two squares need to be the same so they can line up. This bottom square is the same as this one, so we know that that is 10 by 9. And these two squares here are going to be the same. So it is a little tricky to fill out your nets. And again, you don't really need to do this every time. You can just visualize the 6 sides you're trying to find the areas of. But if it helps you, definitely do it. And just make sure you're able to identify what a net is and how it folds back into the shape. So we have a side that's 90. We've got 2 of those. We've got 2 sides that are 72 and 2 sides that are 80. So 90 plus 80 plus 72, and we can just multiply that total by 2 because there's 2 of those, and we get 484 inches squared. And again, you don't need to draw the net every time, but if it helps you, definitely do it. All right, now we have another triangular prism. Let's try it without the net this time, just to see how we do. Now this triangle here, we're given the right angle. It's a right triangle, so we know that the area of this triangle, the area is 1/2 base times height, and we know the height is 8 and the base is 6 because they're perpendicular. So for the volume, area of the triangle is 1/2 times 6 times 8, and the distance between them is 6 right here. So that volume would be 3 times 8 times 6. We get 144 centimeters cubed. So now we need to find the surface area, and if we're trying it without the net, we know we have 5 sides. We have 2 triangles, 2 of this triangle. And so that's 1/2 times base times height. So 1/2 times 8 times 6 is 24. We have 2 of those. And then we have 3 rectangles. Well, this rectangle here is 6 by 6. That's 36. This rectangle here is 8 by 6, which is 48. And this rectangle here is 10 by 6, which is 60. So if we add all those up, we get 192 centimeters squared. And there's your surface area. So it is possible without the net. If the net confuses you and you can just sort out the sides and add them up, that's totally fine too. All right, one more example, and this is actually a cylinder. So a prism is a shape that has sides, and a cylinder doesn't have any sides, but it does work the same way. The area of a cylinder is just the volume of a cylinder, sorry, is just the area of the base, which is a circle, times the height. And we know to find the area of a circle, it's pi r squared. And so we can find the volume here by doing pi r squared, which is 9, r is 9. So pi times 9 squared, times the height of the cylinder, which is 11. So 3.14 times, oops, that's 314, times 9 times 11, we get 2,797.74 kilometers cubed. Quite large. Now, the surface area is a little trickier, and it might help to consider the net here. So this is what the net of a cylinder looks like. We have the 2 circles, top and bottom, and then we have the curved surface, which is actually, if you unroll it, a rectangle. The thing with this rectangle, though, the width of it, the length or the width, whichever one you make it, the length here is the height of the cylinder, which is 11. But the other side, the long, I guess it is the length, we would say, is the circumference of the circle. So that's 2 pi r for the length of that rectangle. And so then we have the area of the circle, and then the area of the rectangle. So let's find those values. So the area of the circle is 9 times 9 times 3.14, which gives us 254.34. Okay, and the area of the rectangle, 2 times 3.14 times 9, which is the circumference, times 11, which is 621.72. Now we can just add these 3 values up for the surface area, which is 1,130.4 kilometers squared. Slightly trickier on the cylinder, just because you also have to use what you know about circumference to figure out the area of that long rectangle, but hopefully nothing you haven't seen before. So in general, though, the volume of a prism or cylinder is the area of the base times the height of the prism or cylinder. For surface area, simply add up all the areas of all the outside edges, and that gives you the total area of the surface of that figure.